Hello there. Welcome to the last session, that's section 6 of Unit 4. And as a matter of fact, the last session of this model, that's atomic heat and optics. And for this section, we'll be looking at transistors. Let's check out the objectives of this section. The first objective is to know what transistors are, understand the typical and basic characteristics of transistors, know the types of transistors, understand some basic transistor circuit and function, and learn about transistors switch. Transistors. So a transistor is a device that can amplify and produce an output signal with more power than the input signal. The transistor is an essential ingredient in every electronic circuit, like the amplifiers, oscillators, computers, and others. There are three terminals of a transistor. That is a collector, a base, and an emitter. And we are going to treat these ones as labels. A transistor has two essential functions in an electronic circuit. That is, one, as an electronic switch, and two, to provide an amplified current. There are two types of a transistor. That is the NPN transistor and the PNP transistor. So let's look at how a transistor is connected. The first point we are going to note is 1. The emitter terminal is connected directly to the OV line. And here our OV line is this particular one. So here's the OV. 2. A resistor has been added to the base terminal. This is also to limit the current flowing in the base circuit, as only a small current is needed to switch the transistor on. And lastly, the load or the lamp, that is this one, is connected to the collector circuit. Now, let's look at the function of a transistor. At any given time, a transistor may be 1. Cut off, no collector current. 2. In the active or linear region, some collector current flows. And 3. In the saturation, almost constant maximum collector current flows. Now, with the cutoff region, this part of the characteristic, when the voltage in is between 0 and 0.7 volts, shows when the transistor is completely switched off. No current flows through the base emitter junction, no current flows through the collector, and the voltage across the transistor is equal to the supplied voltage. With the linear region, when the voltage in reaches 0.7 volts, it is critical moment for the transistor because this is the point where the transistor just starts to conduct electricity through base emitter junction. There is a current gain formula, that is IC over IB, where IC is the collector current and IB is the base current. Now let's look at the application of a basic transistor circuit. A basic application of a transistor is a transistor switch as a switch. An example is shown in the figure below. In this application, a small control circuit enables much large current in other circuits. And 1. When a mechanical switch is opened, there is no base current. Therefore, there is no circuit current. The lamp is off. When the mechanical switch is closed, the base rises to 0.6 volts. And lastly, as collector is more positive than the emitter, it is the collector current that enables the lamp to emit light.